Okay, I'm going to do a warm up really quick before you do your Target A workday. So your Target A workday is going to have you do one problem at a time. And in the problem, you're going to do everything we've done so far. So finding horizontal, vertical, and holes. You're going to be finding those. And sometimes you're going to have them and sometimes you're not. So this is the order that I would do them in. The first thing that I would do is do your horizontal asymptotes because I don't want you to factor this yet. Remember, in order to find your vertical asymptotes, you're going to have to factor the top and the bottom. First, I don't want you to do that yet for the horizontal asymptotes because if you remember from class before, the horizontal asymptotes are where we look at the degree on the top and compare it to the degree on the bottom in order to use our three rules that are here. So when we did horizontal asymptotes, we took notes on, we have to compare the degree on the top with the degree on the bottom. So before I factor this, I'm just going to look at the degree on top. The degree on top here, I hope you agree with me, is 2. Remember, the degree is the biggest exponent. The degree is the biggest exponent. So the degree on top is 2. The degree on bottom is also 2. We take the biggest degree, the biggest exponent. So it's not 2 over 2. I'm just looking the degree on the top. So for my horizontal asymptote, the degree on the top is equal to the degree on the bottom. So I want to know what rule that follows. So let's go back to my notes. You have notes on this on page 3 or 4? 3. Degree on the top is equal to the degree on the bottom. Well, then that means then y is equal to the leading coefficient on top divided by the leading coefficient on bottom. Alrighty. Well, the leading coefficient, your leading coefficient is your number in front of the variable. The variable is the letter. So the number in front of this letter right here is 1. And the number in front of this variable right here is 1. So my horizontal asymptote is going to be equal to y equals 1 over 1, the leading coefficient of the top divided by the leading coefficient on bottom. So putting this all together, my horizontal asymptote is equal to y equals 1 over 1, which is 1. So that's the horizontal asymptote of this problem, y equals. Don't forget that horizontal asymptotes are in the form of y equals. Alrighty, I'm done with the horizontal asymptote. Now I need to check for vertical asymptotes and or holes. This step is done for you. We took notes on this on page 4, and I do this part together. And that's where I follow these steps that I have here. Remember, on page 4, we did vertical asymptotes and holes, and I need to factor everything. I'm going to factor the top and the bottom, and then we will talk about what happens after that. So I'm going to do some work over here. There's a lot of work that goes for these problems. So now for my vertical and horizontal asymptotes, I'm going to factor everything. So I'm going to factor over here. I'm going to rewrite my problem down here so I have room to show you my work for factoring. So f of x is equal to x squared minus 9 divided by x squared plus 10x plus 21. Remember, my goal is to get you more familiar with these types of problems. When you see two terms that are being subtracted from each other, the very first thing you should think to do is difference of two squares. Difference of two squares is where I take the square root of the x squared. I leave the subtraction sign out of it. I leave it out, and I take the square root of the number. Okay? You have to show some sort of work for your factoring. The square root of x squared is x, and the square root of 9, remember we're leaving the negative out, is 3. So I have x and 3. Remember, when I do the difference of two squares, I take the two things and I add them together, and I take the two things and I subtract them from each other. So I'm going to rewrite the top of this part of the equation as x plus 3, x minus 3. I factored the top. And now I need to factor the bottom. I want to find the factors of 21 that add to 10. Well, if I find the factors of 21, it's actually 1 and 21 and 3 and 7. I hope you agree with me that 3 plus 7 would give me 10. So x plus 3 and x plus 7. I'm not done. You have to watch one more video, one last video.